Welcome everyone to the session of the day. We have Peter and Timothy talking about Fedora IoT and Fedora CoreOS. We'll take questions at the end of the session, so please put them in the chat. Go ahead, Peter and Timothy.
Hey, thank you. And hi everyone, welcome. All right, we are going to talk here about Fedora IoT and Fedora CoreOS, where you should use one or the other, and all things about those two projects. So I'm Timothy Javier, and I'm with Peter Robinson, and we both work at Red Hat on the IoT and CoreOS teams. All right, so what's on the agenda, right? We will first start talking about the common parts. A lot of things are shared between the two projects, and you'll see that we have a lot in common between Fedora IoT and Fedora CoreOS. And then we'll dive into the specifics for Fedora IoT and then for Fedora CoreOS with some use cases and examples at the end. All right, so Fedora CoreOS, Fedora IoT, what do we have in common? Well, the first thing is it's in name. We share the Fedora project. We're based on the Fedora project. We share the RPMs. Everything that goes into those projects comes from Fedora and from Fedora packages. Of course, both systems are, we are in the container days, so both systems are heavily focused on containers. We ship Podman, and on Fedora CoreOS, we also ship the Mobile engine for compatibility. And finally, we also have SO Linux enforcing by default, just like all Fedora projects. But here it's even more important because it helps isolating each containers, one from the others, every container that we run on the system, and also helps protecting the host system if one of the container ever gets compromised by somebody malicious. All right, go ahead, Peter.
Nick. Yeah, so as Timothy mentioned, both platforms use rpm-ostree. It's a Git-like platform for your operating system. We ship as large sort of decimal versions, so 32 is Fedora 32, plus the date of the compose, plus any incremental numbers up there. That, so you can have multiple builds a day if necessary. Atomic updates, rollbacks, package overrides, and all the fun bits and pieces. It leverages read-only file systems, so root, user, and boot are read-only. Data goes in var, like on a lot of standard Linux systems, and obviously configuration in etc. And it ensures like all the changes to the file system are tracked by rpm-ostree to give you that sort of nice atomic update and rollback, and also allows you to track and provide extra security with things like your read-only file systems, so that things can't accidentally or maliciously be damaged. Next slide. And again, we'll go into some of the Fedora IoT specific features. Yeah, so as I mentioned, it's immutable infrastructure. You can layer packages within Fedora IoT, obviously, but we prefer not to. They can cause issues with upgrades and various other bits and pieces like that. And the aim with Fedora IoT is to have just enough OS on the base sort of container platform, hardware enablement, networking, container management, that sort of stuff, and then literally run everything else in containers. At the moment, Fedora IoT is not quite as slim as I would like it to be. There is ongoing work there around being able to slim it down more, but like everything, things take time, and we're quite a small team. So we need to focus on sort of a balance of features and functionality versus slimness. We use TPMs extensively to provide hardware roots of trust, to enable the integrity measurement architecture to provide data security for edge devices. You know, a lot of IoT and edge devices are deployed in quite significantly different circumstances to your average enterprise server in a data center, where the data center has 4 walls and an access control list. You know, I've had and been involved in customer deployments where, you know, IoT devices are strapped to oil pumps and to poles and various other places with a lot less security. So Fedora IoT has quite a big focus on security enablement, and we're doing a lot of upstream and standardization work for enabling that. We're working on Ansible collections with a focus on edge. So an Ansible collection is like a bundle of specific sort of plugins and playbooks and what have you for Ansible, for things like rpm-ostree Network Manager that are explicitly focused on the edge and IoT use cases around deployment updates and things like that. And yeah, so we should have the first release of that shortly, because obviously with the Ansible stuff, because we don't ship things like DNF and some of the sort of tools that people are used to in traditional Fedora instances, you know, the plugins and what have you for Ansible are slightly different in that regard. So we're aiming to put together like a curated collection for Edge. Green Boot is a little project for updates and rollbacks. So you can set up a set of health checks. So OS3 applies an update and you reboot. And if it doesn't boot or you can't connect to the network or the update platform or things like that, you can specify sort of points at which it will roll back to the previous version so that you don't end up with a brick system. We're moving to use Image Builder with the OS Build plugins for the actual, you know, creation of the installer and updates process, and we're you know, that's in early phases at the moment, and we should be moving all the Fedora IoT stuff over to that in the Fedora 35 timeframe, and that will give a very similar or almost same experience as the downstream product that Red Hat has called RHEL for Edge, which is using Image Builder exclusively for that. The creation of images and updates and all of that sort of stuff. Next slide, please. Yeah, so we're targeting 3 main architectures, obviously x86-64, ARM64, and ARMv7. We have support for the container build pipeline for the 2 64-bit platforms at the moment to enable people to build containers with the contents of Fedora to run on Fedora IoT. We only actively support devices with UEFI across all 3 of those architectures. So all of the devices that we support like boot and run in exactly the same manner, no matter what the architecture. And we support, like on the ARM side of things, we support all the SoCs and ARM platforms that are supported in Fedora, but we explicitly require SBBR or EBBR support, which mandates things around firmware provided device trees or ACPI tables and things like that. Some of the examples of the platforms we support, the Jetson Xavier series, we should have the Jetson Nano support finished up for Fedora 34 shortly. Compute Labs Fitlet 2 is a great little x86 Atom-based device. Some of the solid run devices like the Humming Comb and the Hummingboards. I noticed I spelled the Hummingboards incorrectly there. And obviously some of the Raspberry Pi devices are supported as well. We'll have better Raspberry Pi 4 support coming in Fedora 34 with the beta due out for that really, really soon. Yeah, so we have quite a range of devices support. Unlike CoreOS supports bare metal, and Timothy will go into that, but a lot more of their focus is on sort of cloud and vert-based platforms, where in the Fedora IoT space, we're very much focused on sort of small edge physical hardware devices that can be deployed into the field. Next slide, please. Yeah, and so we've got a prototyping platform for onboarding of devices. It's a little rudimentary at the moment. We have on our plans to improve it some more. And the idea is that it's a minimal touch. And eventually with some of the standards like the FIDO IoT spec, the intention is to be able to have essentially a zero-touch onboarding platform. There's the GitHub URL there for people that would like to contribute. And yeah, it is a little bit rudimentary at the moment, but hopefully it will improve quite a bit before too long as we get, as the team grows, to be able to improve that. Next slide, please. And yeah, as I mentioned earlier, we have a big focus on security. You know, being able to provide a similar level of security that a physical platform has in a data center without the data center, and you know, access control lists. So TPM is critical for hardware roots of trust and non-recoverability of critical information. The TPM is also used for the integrity measurement and attestation related stuff. We have the basics of that in Fedora at the moment. We're hoping to expand out the ability for enabling that and making it more straightforward in Fedora 35 with regards to signing all the binaries on the build system, and so that you will be able to track the sort of security of the binary from the moment it was built on the Fedora build systems to the point at which it runs, and the system can verify that all on its own. Secure boot to ensure a hardware root of trust boot sort of chain right from the firmware through the bootloader to the OS itself, because obviously if you can't trust the entire boot chain, your OS as a whole isn't able to be trusted. But we're also working with hardware vendors and upstream standards projects around emerging hardware security enclave technology and emerging security initiatives like Parsec, which is a initiative out of ARM, which we've been working closely with them on. That was included in Fedora 33 and was downloadable, and we put together a demo with dbus, so you can actually enroll all the network manager credentials for VPNs and Wi-Fi and various other bits and pieces like that into the TPM. And you know, when the system boots, it'll automatically connect to the Wi-Fi network and automatically bring up, say, a WireGuard VPN with all of those credentials stored in the TPM and completely non-recoverable. If someone gets onto that system, you know, the credentials aren't stored in sort of flat files in the etc file system, where if the system's compromised, people would be able to get access to, you know, the corporate Wi-Fi or the corporate VPN, which obviously would cause further problems. Yeah, and so and we're involved in a number of other initiatives around security and sort of industry engagement, such as the Trusted Computing Group, IETF, and FIDO organization. Next slide, please. And where are people using Fedora IoT? Well, I was working with a few Red Hat customers over the last couple of years, prototyping Fedora IoT in various industrial use cases, including like vision and AI related bits and pieces. And speaking with the community, we've had actually a huge uptick in interest in Fedora IoT since we became an addition in Fedora 33. And there's people sort of prototyping Fedora IoT instances in spaces like healthcare and aged care, for running 3D printers, retail and point of sale, a lot of home automation and monitoring in the community, and even had 2 people using it actually for home brewing. So certainly lots of wide interest. Also a few groups of people playing around with Fedora IoT and projects like ROS for robotics and various other bits and pieces like that. Yeah, there's certainly the community is certainly starting to use Fedora IoT in some quite many and varied and interesting sort of use cases. And I'm actually looking forward to actually trying some of the homebrew of those people once we're able to travel post-lockdown and COVID. So that will be very exciting. And I think that was my last slide. So I will now hand over to Timothy to cover some of the Core OS specific features and use cases.
Thank you, Peter. All right, so let's talk a bit about Fedora Core OS. So the main philosophy behind Fedora Core OS is that we have automatic updates. The idea is that we try really, really hard and we make sure that your system is always up to date and gets updated automatically. So that means that you, as an administrator, you do not need to interact with the system, with the Fedora Core OS system to get it updated. It does that by default. So if you stay up to date, you get security fixes applied, of course, and you get also all the latest features. In Fedora Core OS, one specific thing that we want to point out is that we have all the nodes, whether it is in a cluster or in a system as you deploy bare metal, start from the same point. So everybody has the same image. Everybody starts with the same image, and then we use Ignition to provide the configuration that actually make your system useful for something, for doing something, for deploying applications or workloads. So yeah, and Ignition is first boot mechanism. That's one of the things that runs on the first boot and only runs on the first boot and will do the setup for your node for your system. If one of the main advantage of Ignition is that it's the same. It works the same way if you're on bare metal or if you're in the cloud. So if you have something that is working in the cloud, you can do that, move to bare metal or do the other side, and that's not an issue. Another point behind the Fedora Core OS philosophy, the Core OS philosophy itself is we want to have as much as possible immutable infrastructure. So the thing is, if you want to have a change in something that you have deployed previously, one of the options is to simply redeploy everything. Not necessarily like losing your data. You can still keep your data stored on your disks, but you will redeploy the system, and with it, you will get the new configuration that gets deployed via Ignition. Of course, for all that, you have to run your software in containers, and that's the main point of Fedora Core OS and Fedora IoT. You want to run all of your software via Podman, for example, to run in containers. The idea behind containers here is that it's completely related to the auto-update features. If you want to have auto-updates work great and work at scale, you need to make sure that your applications are running in containers so that they are isolated from host updates, and host updates can happen at any time. So automatic updates, yes, that's the idea. That's one of the things in Fedora Core OS. We have that enabled by default, and you can configure that. You can configure when they happen. You can configure if you have multiple systems. You can have multiple system reboot in lockstep, one after the other, for example, with a specific daemon to do that. And our main goal is to make those updates highly reliable. So We have a lot of testing happening in the CI pipelines to make sure that the system won't break during updates and that all updates are fine. To do that, we also have multiple streams. So we release multiple streams, and you can test upcoming versions of Fedora CoreOS before they are pushed into the stable streams. So there's this testing stream and the next stream, which goes even further ahead. Right now, it's going to be based on Fedora 34, for example. So you can manage the update rollout across a cluster, for example, if you have a lot of systems. And if for whatever reasons, if we miss something or if something very specific broke, you can always roll back, because with rpm-ostree, you can roll back to the previous version. Another important part of Fedora CoreOS is the automated provisioning part. So we use Ignition. With Ignition, you can specify in a declarative way how you want your system to be configured on first boot. This makes really easy to reconfigure and reprovision the node, because once you've written the configuration once, you can recreate a new node with the same configuration, and it will work instantly. And it's, as I said before, it's the same way to create and provision a node. It was the same way on cloud platforms and on bare metal, which is highly efficient. So with Fedora CoreOS, right now we only support one architecture. It's 86-64, the classic one. There are work in progress to improve our support for more architectures, just like the one which are currently supported in Fedora, but that's not done yet. There's work in this unofficial build, I think, for Arch 64, but it's not ready yet. Of course, we support bare metal, so and on top of all the cloud platforms, the very popular cloud platforms that we already have support for. All right, and finally, so usually when you hear about Fedora CoreOS, when you hear about CoreOS, you hear about Kubernetes and the clusters and system, highly clustered systems with a real large deployments of systems and things like that. And Fedora CoreOS is great for that, and you can use that as part of OKD, for example, or another Kubernetes distribution. But it's not enforced, and you don't have to do that. You can also run Fedora CoreOS nodes by themselves, standing alone, not in especially large clusters or in small clusters. You don't have to run Kubernetes on top of Fedora CoreOS, and so we usually get asked that, what can I do with Fedora CoreOS as a standalone OS? And so here is an example use case. It's deploying a Matrix home server on top of Fedora CoreOS. So without Kubernetes, it's purely podman based, and essentially it's deploying a set of containers on top of the system. Everything is declared in the initial config. So if you boot this node right now or in 2 months or whatever, you can boot as many nodes as you want, and they will all get the same setup working by default automatically on first boot. So here's the links to the repo for the example configurations and what you do about that. And all right, and I think that's it for me. We have here a collection of links for to help us get involved if you're interested in those projects. So we highly tied, really close to the Fedora project, because we're part of the Fedora project, of course, and so all of the communication mechanisms and the way to interact with us and the projects are linked there.
Awesome. Thank you for the great talk. We have a few questions, so let's see if we can quickly get through them. The first one is, if you wish to create an ephemeral environment, is PXE booting FCOS a reasonable option? It seems PXE booting and rpm-ostree are incompatible.
So it's a great option. It's really recommended if you want to have an ephemeral system and you want to reprovision every time you reboot, and that's completely compatible. That's something that we have documented in the Fedora CoreOS documentation, and yeah, PXE booting is fully supported on Fedora CoreOS.
All right. The next question is, would you consider removing Moby engine and just installing Podman Docker now that Podman supports API v2?
Yeah, I say it's from downward. That's a trick question, and I guess this will have to be discussed in the Fedora Core OS meeting. Maybe we could start wondering about that. But
yeah, we already made that decision in Fedora IoT from the outset.
All right. The follow-up question is, would you consider removing run C and using crun in order to shrink the image size?
I believe crun is already the default in Fedora as a whole. And I believe crun is the default in both Fedora IoT and Fedora Core OS.
Okay. The next question is, are there plans for better integration, packaging of Cryo and Core OS?
I think Cryo is already packaged in Fedora, and so you can install that on Fedora Core OS or have that installed in a different way. I'm not 100% sure, but
I believe it's a Fedora module. I'm not sure how Core OS supports the module side of things. I'm pretty sure it does.
All right. Next question is, would you consider supporting 2 Core OS layers, a base layer with only podman and then have another layer with Kubernetes/Cryo?
that's I don't know right now. That's a possibility. We reach out to us. I don't know. Maybe. Yeah, I don't know.
All right. I guess Dan reach out for further information. The next one we have is, can you share some thoughts on commonalities and differences to Flatcar Linux?
All right. So the short version is that Flatcar is a continuation of the containers projects. So it's Gentoo based, and we're Fedora based, and so we use Fedora RPMs as the basis for the project. And with
All right.
technologies, some technologies, but yeah.
Okay. Thank you for answering all the questions. Another great talk. We are out of time here now. See you on the next session. Thank you once again, Peter and Timothy.
Thank you.